Well, nobody came to my session this morning, so I will just do a couple recordings and post these. So you're starting to look at RLC circuits, so circuits with resistor, capacitor, and inductor. And you'll be looking at the response of those. So these are called second order circuits because their behavior is modeled with a second order differential equation, and so we have different methods for solving that. But the first thing you have to do is to be able to figure out what is the state of the circuit at different times. So we're supposed to draw the configurations that appropriately represent the state of the circuit at t equals 0 minus, t equals 0, and t equals infinity, and use them to determine the different things. So 0 minus means right before the switch action, and then 0 means right after the switch action. So it closes at t equals 0. So it had been open for a long time. So what that means is that the capacitor was acting as an open circuit and an inductor was acting as a short circuit. So it would look like this, where our inductor is up here and the capacitor is right here. This is 12 volts, this is 3 ohms, this is 4 ohms. So at time t equals 0 minus, so before the switch action, assume it had been like this for a long time. So is there any current? And the answer is no. There's no current through either the inductor or the capacitor because it's an open circuit. So we know that IL of 0 equals 0, or 0 minus, because this is right before the switch action. And we have IC of 0 minus also equals 0. Okay, well, how about the voltage? Just because the current is 0 does not mean the voltage is 0. Well, for the inductor, the voltage is 0. That's VL of 0 minus is 0 because it's acting as a straight wire and there's no current going through it. And so there's everything from here to here is at one voltage because they're all connected and there's no current, and so there's no difference between the voltage on either side. But on the other hand, all of this is at the same voltage as well. And if you make the bottom ground, and we have a 12 volt voltage source, then the voltage on top is 12 volts, and the voltage on bottom is 0. So if this is plus and this is minus, then we have VC of 0 minus is 12. So we have that. And so once we have that, we can use that to draw what the circuit looks like right at 0. So at 0, we close the switch. And right then, our inductor will act as a current source. So this is just right at that very moment. And our capacitor will act as a voltage source. Alright, so now let's see what we've got here. So we have the current through the inductor has to be 0. And so That means that because it can't change instantaneously. So that means we have no current in this branch. So all of this current has to be 0 because it can't change instantaneously. And the voltage here cannot change instantaneously. So we know that we have to have the 12 volts right here. So what's going to happen at 0, the voltage across the inductor can change, even if the current can't. And the current through the capacitor can change even if the voltage does not. And so we know we've got a 12 volt voltage difference across the capacitor. And so if we have 12 volts here and 0 here, then we know the current is going to be going this way. No current is going to go into this branch because there is no current in that branch because the current through the inductor is 0. And so all the current has to come up here. And so that is the direction of the current. And so we have the current going through the 4 ohm resistor, and we'll have that current. So let's see, so what do I have over here? So IL of 0 is 0. IC of 0 is going to be the current through that 4 ohm resistor. The voltage right here has to be 0 because it's all connected to ground. So the voltage all over here is 0. So that current is going to be 0 minus 12 because it's 0 on this side, 12 on this side, over 4 equals -3 amps. So the current through the capacitor is -3 amps. So interestingly, I drew it going the wrong direction. Not wrong. I mean, that is it. You know, going in that direction. That's the direction. You know, I'm supposed to be drawing it like that, going in that direction. But it is -3 amps. So IC of 0 is -3 amps. So what does that mean? VL of 0 is? Well, it's 12 volts on this side and 0 volts on that side. So VL of 0 is 12. The reason that it's 12 volts on this side of the inductor is right now there's no current, so it's all the same. Right here is all 12 volts. All right, now let's see what else we're supposed to find. What everything is at infinity. So at infinity, once again, the capacitor will be an open circuit and the inductor will be a short circuit. So let's see. There will be no current through the right-hand branch because we have a short circuit right here. So all of the current is going to go that way. So IC at infinity is going to be 0. IL at infinity is going to be 12 over 3, or 4 amps. VL at infinity will be 0. There's not going to be a voltage difference across that inductor. And VC at infinity will also be 0 because it is in parallel with a short circuit. So 0 volts and 0 amps.